Hi, Mr. Biggers here, and today I'm going to very quickly run us through our Unit 4, Lesson 6 on dilations. A dilation is a proportional increase or decrease in size in all directions, okay? A dilation is a non-rigid transformation. So it is not like a translation, it is not like a reflection, it is not like a rotation. It's going to change the size of the figure. Dilations do not preserve distance between points, but they do preserve the angle measures because it keeps the same shape. A scale factor is the ratio that describes how much the shape has been enlarged or reduced in a dilation. So to find the ratio or the scale factor in a dilation, you want to take the x-coordinate of the image and then divide by the x-coordinate of the pre-image. So in other words here, you want to take the new figure and divide it by the old figure. That is going to get you a scale factor of dilation. Now, for a dilation that is larger than 1, that is going to grow in size, okay? For a dilation that is less than 1, it is going to shrink in size. There we go, shrink. Okay, so in introduction, we have triangle PQR. It's dilated to create triangle P prime, Q prime, R prime. Each point has been dilated using 0, 0, or the origin as the center of dilation. We need to complete the table below. So we need to identify the x values of the pre-image and then the x values of the image. So the x value for coordinate P right here is 1. The x value for Q is 3. And the x value for R is 1. Now, in the image, the x value for P prime is up here. It is 3. The x value for Q prime is 9. And for R prime, it is 3. So to find the scale factor, we are going to take the image, the coordinate of the image, and divide by the coordinate of the pre-image. So I have 3 divided by 1. That gives me a scale factor of 3, okay? The one below it is 9 divided by 3, which gives me, once again, a scale factor of 3. Okay, and really you only have to do 1 or 2 points to find this rule, because you're going to see here that even on this third one, the scale factor still comes to 3. Now remember, if that scale factor is a number that is larger than 1, that means your shape is growing. And you can easily see here that the blue triangle became 3 times bigger and turned into the orange triangle. The algebraic description for this is going to take your x and y coordinate, and all it's going to do is multiply both coordinates by the scale factor. So the scale factor here is 3. So you have 3x, 3y. And it's as easy as copy pasting this down the whole way, because that's how the algebraic description is going to apply to the whole entire figure. Each of the coordinates multiplied by 3, x and y. We're going to go on to the back side here where we have example 1. They want us to find the scale factor and write the algebraic description, okay? So the pre-image and the image. So the pre-image is before the movement. So that's going to be K, W, and T, okay? The image is going to be K prime, W prime, and T prime. As I mentioned on the last one, you only need to use 1 or 2 points, not all 3, to find the scale factor. So let's look at T, okay? Pause the video and see if you can identify the x values of T and T prime. Okay, I'm going to go ahead and do it. So the x value of T looks like it is -3. The x value of T prime is -2, okay? We're also going to double check this with W. Like I said, you only need 1 point, but I'm going to do 2 just for good measure. So W, the coordinates for the x value are -12. The coordinates for W prime, -8. To find the scale factor, you're going to take the new figure divided by the old figure. So the new figure here is -8. The old figure here, -12. So -8 divided by -12, if you type that into a calculator, it's going to reduce it down to 2/3, okay? Now 2/3 is a fraction of a whole number, which means that it is smaller. You can easily see that with the dilation. The orange figure, which is the pre-image, became smaller with the image, okay? We're gonna do the same thing. The new figure down here is -2, divided by the old figure, -3, and we're gonna find that the scale factor once again simplifies to 2/3. You can't have a negative on the top and the bottom of a fraction, so you have to simplify it. Since the scale factor checks out for both of those points, the algebraic description is as easy as writing 2/3 x, comma 2/3 y. Anytime you see a number multiplied to an x or a y coordinate, you know it is a dilation. It has to be the same multiplication on both x and y for it to be a dilation about the origin. Okay, that is the algebraic description. Example 2, graph the image of the figure with the given transformation. Dilation 1.5 around the origin, okay? The dilation is the scale factor. So this is the number that we need to multiply the coordinates by to get the answer. So my coordinates for S, T, and U, I'm gonna write them now. So my coordinates for point S, the X value is 2, the Y value is -2. For T, my X value is 0, my Y value is 3. And for U, my X value is -1, my Y value is also -1. Okay, we have to multiply that scale factor of 1.5 times to try to get the coordinates for the image. This is where you'll need a calculator, okay? So once you multiply this by 1.5, you're gonna get 3, comma -3. Here you're gonna get 0 and 4.5. And this one you're gonna get -1.5, -1.5. Make sure that you are comfortable multiplying both the x coordinate and the y coordinate by a decimal to get a final answer. This is the coordinate of the image. Now the problem would like us to graph the image. So I'm gonna go ahead and plot these points now. So S prime is at 3 and -3. So that's right here, S prime, okay? T prime is at 0 and then up 4.5. So I gotta go halfway to 5. That's T prime. And then U prime is -1.5, -1.5, right here. I'm gonna go ahead and connect those dots really quickly here, so that way we can see our dilated triangle. Let me try to get a straight line here. So that triangle is 1.5 times larger. It's not that much bigger, but it does make a difference. The dilation, it multiplies the sides. This is gonna be an example for you to try, so pause the video at this time, see if you can try example 3. I want you to find the coordinates of the vertices when dilated by a scale factor of 2.5 around the origin. Okay, I'm gonna go ahead and do it now. So remember, a dilation of 2.5 is your multiplication factor. So you need to multiply, this is your times factor. You need to multiply all of the coordinates by 2.5. So F prime, we'll multiply that out. G prime, we're gonna multiply that out. And then I have H prime. Okay, so here I go with my calculator. So I know this is going to be 0 still. -1 times 2.5 is -2.5, easy peasy. G prime is gonna be 0 and +2.5. And then H, pretty easy, is gonna be 2.5 and 2.5. That is how you apply a scale factor. I went through these notes really easy breezy quickly, so if you missed anything, rewind the video at any time. Make sure you listen to what I described, and you should be able to easily understand an enlargement or a shrinking of a figure, also known as a dilation. Thank you for watching.